Okay, let's get started because Jai will come here later. He has a forgotten meeting or something else, and Vesla will come here soon. Okay, folks. However, we have the video recording, so let's get started. And so let me first compare LaTeX with Microsoft Word. So LaTeX, you need to learn a lot of comments to use LaTeX, and the Word is very easy. What you see is what you get. Super easy. And the LaTeX, it is a typesetting system. It means you cannot use only LaTeX to generate papers. You can use it to generate any kind of documents, even let's say music script. Okay, and however, it is command based. And so, because this is a command-based, you need a rendering engine. So, why those top conferences, CPI, CV, they all provide the templates for their paper submission because LaTeX is a typesetting system, so you can very easy to control the format. That is the advantage of LaTeX. And another advantage of that is it can generate a very elegant and complex mathematical equations. That is the limitation of Microsoft Word. But however, what is the disadvantage of Microsoft Word? This, because you have the freedom to control every detail of the format in a Microsoft Word. So you need to pay attention to every detail. That is the troublesome issue. Okay? If you make some mistakes, many people they are aware of those mistakes. In Microsoft, there is a very powerful tool named Style, but it is an advanced feature. Only a few users know and can control the complex style. There's also advantage of Microsoft Word because this is a series of software products in the office. So it can easily integrate these features with Excel, SS, and PowerPoint. Okay, so let's see two most widely used LaTeX systems. First is the local solution. There is an editor, that is a Text Studio, and there is a rendering engine. Usually it is installed through the MicTeX variation. And this viewer embedded, built in the Text Studio environment, and it's free, totally free. Okay. And if you want to share your LaTeX file with your collaborators, not difficult. Through Dropbox, Google Drive, or even OneDrive, it's all possible. Okay, but you cannot do the online co-editing because you need to sync your files with your friends or classmates. And that's another solution is a cloud solution. The leading company is the Overleaf. So it integrates its editor, rendering engine, and the viewers into a same web-based user interfaces. But however, because you need to use its computers to render your PDF file, so they are either a free subscription, but you will have limited rendering resources, or you have to pay $21 per month to get more computational resources and more feature. For example, as we mentioned the previous week, the Grammarly is a very good sentence character or suggestion provider, and there is an embedded AI-based sentence generator built in the Overleaf platform, but you need to pay to get the feature. Okay, so let's see. This is the user interface of Overleaf. And now, I believe. Do you have the Overleaf account now? Overleaf? No. Can you have right? And Ding, you don't, right? You have. You have. Okay, so only Nino. So fine. Nino, you can just log in. Go to the Overleaf, and use your, for example, Google account or Facebook account or to create an account. It's very easy. And then you will see these user interfaces. Here, there are several projects I created. So it's show 2 years ago or 10 months ago or a few months ago. So, okay. And when you just click any of them, then you will go to the editor and the viewer user interfaces. On the leftmost, it will show all of your files in the project. And if you click any of them, the content of the file will show in the editor panel. And if the file can be successfully compiled into a PDF, then the PDF will show in the viewer panel. So it's intuitive. And this is the resources of the Overleaf free plan. You can only have a single collaborator for a project. Okay, so this is useful, but this is limitation because if your paper has, say, 2 co-authors, then there will be 3 members need to edit the file at the same time. Okay, so you will get restricted by the free plan. But however, there is an alternative solution because Overleaf allows user to create the editable link. So you can create it and share the link to the 3rd or 4th collaborators. They don't have, when they click the link and get into the Overleaf user interface, they can also co-edit the file online. And however, there's a more important issue is the provided free computational resources or the rendering time. A few months ago, Overleaf is still very generous. He gave most users through the free plan sufficient rendering time. But recently, because Overleaf need to make money to support its operation, so Overleaf gradually reduces the rendering time. As a result, now if I want to compile a very small file, for example, my resume, I can still use Overleaf because it is very small. Just in a few seconds, the PDF was generated. But for example, for our CPR 2026 submission, because there are a lot of figures in the file, it takes 5 to 8 seconds to finish the rendering process. It exceeds the limit of the free plan. So I will launch the build process, but it stopped in the middle. I cannot get my PDF file. This is the problem. So how I do? I need to go back to the local solution. So the local solution is the Text Studio. So this is similar to the yes, please.
So can we just edit Overleaf and then use the local Text Studio to render it?
Of course you can. Yeah, you can edit your file on Overleaf, but you need to download the whole project as a zip file and unzip the zip file, and then yes, you can. Yeah.
I mean, in the free version of Overleaf, do they limit the number of compile time?
Yes.
So we cannot recompile every time we share the code.
Sorry, I don't know. Do you mean we cannot compile individual files?
in the free version of Overleaf, when we change the code in LaTeX, we need to click compile to make it.
Okay. Oh, okay. Yeah, there are two options. Let me show you. Okay. The first option, let's go to the overlay. Okay, so let's assume this. Right. Hi, good afternoon. That's fine, don't worry. Okay, so let's now this. Okay, let me see. Yeah. Okay, and view. Split view. Okay, so alright. So here, if you want to compile a file, you need to click the recompile button. Okay, but however here there is an auto compile. It's on or off. If you put it on, then when you edit the text, it will sense, do you have any modification? If yes, it will launch the rendering engine in the background and render the PDF every a few seconds.
When we click compile, we need to use like the CPU of the Overleaf server to compile. I mean, do they have a limit to compile like a T time per hours or 10 time per hour?
No, basically, as far as I know, no. There is no limit of the quota. The only limit is the seconds you have to compile a single file. So, okay. So if your file is small, okay, that's fine. You can compile it 100 times if you want. Okay, yeah. Right? Okay, so this is Text Studio's user. In addition to Text Studio, there are some LaTeX editor. But from my personal opinion, I personally prefer Text Studio. I think it is the most advanced LaTeX editor, a local solution. Yeah. Okay, of course, if you want to separate the editor and the viewer, no problem. You can just so this is the Text Studio editor, and this is the Text Studio viewer. If you have multiple monitors, this will be very useful. And of course, Overleaf can do it. Yeah. Okay. So this is the Overleaf, the editor, and this is the Overleaf, the viewer. All right. Okay. So let's talk about the rendering engine. Here, this is the Text Studio options. So, and for the upper side, that is the rendering engines, and for the bottom, second region, that is the rendering engine for bibliography. So there are two. Let me explain the differences. So if I room in this region, you will see here is LaTeX, right? And this is the program to render LaTeX file. And this is PDF LaTeX. Okay, so you can see this is the program in your computer to render PDF from a text file. So LaTeX, PDF LaTeX, XE LaTeX, and Lua LaTeX. So you see there are 4 different types of rendering engines. So what are and all of those files are installed in my laptop. So okay. So here the latest argument is your current editing file. So what are their differences? LaTeX is the oldest rendering engine. It can only generate a DVI file. DVI means device independent file. So it is not a PDF file. But currently, PDF file is so widely used, right? And ICC, VCP, ICP, those type of conferences only accept submissions as a PDF file. Okay. So, there are some people, they are still using the LaTeX rendering engine. But for us, okay, we use the PDF LaTeX rendering engine. However, PDF LaTeX doesn't support the Unicode. It only supports the ASCII code. Okay. So if you want to render some text file containing the Unicode, you need to use this XE LaTeX. And there is a more recently developed rendering engine, Lua LaTeX, because it embeds the Lua scripting language in its search engine. Sorry, rendering engine, but the speed is the lowest. If you don't care about, so for most cases, we just use the PDF LaTeX. That's all. And okay, another one is the bibliography rendering engine or bibliography processor. There are also three different types. The first is BIBTeX, and the second is BIBTeX 8-bit, and the third is Bible. The same. They are all programs installed in my laptop. And the difference is BIBTeX is the oldest one. Okay, it only supports 7-bit. The first, the most widely used 128 ASCII characters in the ASCII code. And BIBTeX 8-bit is the extension. It can support the full ASCII characters. And the new one, Bible, is for the UTF-8. So you can see this is a historical evolution. In the beginning, I only as the 7-bit ASCII codes are enough. But soon, when more people want to use LaTeX to written their own languages, then they need to expand the language set and upgrade those rendering engine. Okay, so let's take a look at what is the BIB file. And okay, so this is what the BIB file is a text file in the left one. So there's a lot of items. So for the let me run it. Okay, so for this item, this is the name of this item, and there are some entries: title, author, book title, pages, year, and DOI. Okay, you just need to fill in those entries, and the rendering engine will compile those source of information to create some strings based on the given style instructions. And then it will generate something like this. Also, you can see this is a name, and this is the title, and this is the book title, page number, and the year. So this is first example, and this is the second example. Yeah. So you can see this is left is the source, and the right is the result. So just fill in, then the LaTeX system will render the result you expect. So you don't need to care about the formatting problem. That is the advantage of LaTeX. Okay, and you will see some auto-generated files. Let me show you where they are. Okay, so Text Studio. Okay, here the BIB file. Okay, so this is my source file. When the rendering system is compiled this BIB file, it will generate this BBL file and this BLG file and this BRF file. So let's quickly take a look. This is the BBL file. Okay, this means a lot of strings. Okay. And this is the BLG file. It is a log of the bibliography rendering engine. And the BRF, this is the back references. So just have a concept, and let's go back here. So this is the BBL file. BBL means bibliography. Okay, what is it? The BIB file is our raw data, but it needs a format instruction to convert those raw data into strings. So this is a string. What is this? This is a string of the name at the beginning, and then the title of this paper, and then in where in the conference name and the page number, and finally this year. So the format is given by whom? By IEEE. Because CPR is a IEEE sponsored conference. So if we submit, every year CPR publish a lot of papers, and they will be collected and available from the IEEE Explore, right? So they need to, those papers need to follow the IEEE format. Okay, so this is the IEEE format for reference. Name first, title second, conference third, and page number, and finally is published year. If you submit your paper to different association, for example, ACM, okay, American Computing Machine, okay, then they will have another format. If you submit your papers to some medical journals, okay, they will have another format. So but you only need to care about the BIB file, and the format instruction will change depending on the papers or journals you want to submit. Okay. But the rendering engine will take care of this step by themselves. So you will have the BBL file depends on your target conferences. Okay, and when the PDF LaTeX want to render the PDF file, they will search or copy those strings from the BBL file and pass it to your PDF file. And this is the second one, the BLG, bibliography log. Okay, it shows the errors when the BibTeX rendering engine compiles your BIB file. So if you don't have you don't get any error messages, you don't need care about this BLG file. If you have some trouble, then for most cases, your editor will notify at least trouble. But if you cannot figure out the trouble through the editor's user interface, you can go directly into this BLG file to figure out what is the problem. You cannot compile the BIB file. So because they are automatically generated, you can be very safe to delete all of them, because in the next round when you compile the BIB file, they will show up again. But you cannot find them on the overleaf user interfaces. So let's go to the overleaf. So here you can only see your
So every time we compile the files, then it will generate a new one, or it will continuously write into
it will overwrite the old one.
override.
Yeah. Okay. Yeah. So here you cannot see those automatically generated files on overleaf, because overleaf hide them. They exist. You just cannot see them. Okay. And the third BRF file, it is a back references file. what is backup references? It is when you use the hyperref package. Okay, the hyperref package will generate something like this: equation 13, and the 13 is in blue. Why is it in blue? Because if you have a PDF and when you click the blue 13, your PDF view will jump to that equation. So that is a just like a hyperlink, but on a PDF file. Here again, when you read the references, you will see 2, 7, 4, and 1, 2, etc. Those numbers mean the cited, which page the citation occurs. Okay. So it is very helpful for readers if they just want to see, okay, where the reference occurs. But however, how can the PDF LaTeX create those features? It needs the backup reference file. Okay. So let's take a look of the backup reference file here. So you can let me enlarge it. You can see the entry is like that. It means for these references, okay, where it occurs. Section 1, Section 1, Section 1. Okay, so the PDF LaTeX will check this file and render the hyperlink on the PDF. Okay. However, this is auto-generated, so it's fine. You don't need to care about it. Okay. All right, and there is a meta comment. Meta comment means there are some short keys. Oh no, not only the short key, but also the user interface. Let me show you. For example, here, this. Okay. Do you see the cursor there? Okay. This means build. Build means when you click the build, it will launch some comments to build your project. But however, you can define what the actions will be taken here. If I click a build and view, it will launch the compile and the view two comments. And if it launches the compile, then here, which LaTeX rendering engine it will use? Here is PDF LaTeX. So that is our default option. And there are several different viewers you can use. The built-in viewer or the external viewer. For example, okay, let me show you it here. Okay, so for the right-hand side is the built-in viewer. If I want to view this file from my external viewer, then I can view, okay, and okay, not this one. Not this. Okay. Let me see. Let me here. Okay, yeah, external viewer. When I click here, okay, it will be launched in my PDF file, and because you can install several PDF viewer software program in your computer, and this is only the default one. You can specify which external viewer you would prefer to show your PDF file. So there are a lot of options available in the Text Studio environment. Okay, however, Text Studio is just a user interface. Who provides the rendering engine? MacText. So this is also a free distribution, okay, and it is best used on Windows. Although it provides Mac and Ubuntu installation file, but according to their document, Windows is still the most stable platform to run this text distribution. Okay. And there is feature. It calls download packages automatically on the fly, because Let me explain. Okay, I believe all of you have the experience of using Python, right? Okay, and you know there are numerous Python packages, and you need to import them so that you can use the command, right? Something like that. In the LaTeX system, you have thousands of packages you can use. If you want to download then install in your laptop, it may take several gigabytes. Okay. And so on the fly means if the MacTeX system found, okay, you need some package, but it is not available in your local computer, it will automatically download the package from its internet repository and install it, and then compile your text file. So it's very convenient and save your disk space. So on the right hand side, this is the MacTeX homepage. It's free. So okay, this is the feature. So let me show you it. This is a MacTeX console. MacTeX console. It's something like this. From the packages, okay, you can see this is all the packages available from the MacTeX library. And if you see the installed on and installed by, then it means on my local machine, those files has been downloaded here, and I can use them directly. Okay. And here is also the document page. This means because there are so many packages, how do you know how to use them? So they provide the manual. They are just the PDF. So if this is installed, let me find this. Okay, so for example, this is installed. Then if I click the algorithm second edition, then okay, here is the manual for this package. It is quite long. It will show you some commands and some experimental results. Okay, so if you need to, okay, for most, if you need to use some specific features from a specific package, you need the manual to figure out what command you should use or what options you should set. Right? So over here, and there is another feature in MacTeX. It can automatically update your package, just like Python, because every Python package has its version. A few months ago, they update, the author of the package updates their version. Okay, so if those new versions are available in the MacTeX repository, MacTeX can help you automatically download or update those packages. Okay. Now let's take an exercise. First, I suggest you to go to the CPR 2026 official website to download the author's kit. If you would like, you can just click the link. Otherwise, you can use your search engine to go to the CPR 2026 author's kit. Okay, it is available here. Okay, CPR 2026 submission template. If you click it, then it will download a zip file. Okay, then let's go. So unzip the file. You will see a folder. Okay. within the folder, this is the template. They are template files, and now you can do two options. First, launch your text studio to open it. Here, new, and open. Go to download, and here. Okay, download. Just click the main text. All right. So now you open. Let me close all other. Okay. Files. Okay, so this is a one. How can I ensure from the path? So this is download author kit main. So this is the one just download, and then click the yes. Any question? No. Oh, just click the build and view. It will first generate those automatically generated files. Okay, and then it successfully compile the main.pdf, and it will show the main.pdf in the viewer. So this is the first option. The second option is upload this zip file to Overleaf. Now let me show you how to do it. So this is Overleaf, and here let's create a new project. So click here, new project, and blank project, and give it a name test 0529. Okay, here this is a empty main text, and let me upload. Upload what? Upload no, not this one. Okay, let me see. Go back here. And where is it? If I want to upload upload a zip file, let me see. I'm not. Okay, let me try. Download this one. Okay, let's try this. Upload. Upload. Okay. Okay. Okay, now we have a new folder, and the folder contains those files. Alright, so okay, let's see if I click the main, alright, and compile it. See whether we can get the result. No, okay. No. Okay, sorry, I cannot find. I remember there's option to upload the zip file to the Overleaf, and it will create a new project. But file. Upload the file. Let's try.
I mean, when you create a project, you have other option like upload.
Yes, I remember so. But let's try new. Oh, here.
Try upload project.
Yes, try. Okay, yeah. That's right. Here is the select zip file, and let's. Okay, this is the zip file. Okay, upload it, and yeah, okay, it looks correct now. Thank you. And it will automatically compile the project. So see, this is circle running. Okay, generate the PDF file. So there are two options to do it. And okay, right? Okay, so as a please.
So the compile, the overlay, when we compile, we don't have the limitation. But if we want to render, then we have the limitation, right?
Correct. You can upload as many files as possible to overlay, but you have the limited rendering time.
So I mean the rendering time and the compile time is different.
The same.
The same?
Yeah, compile time is rendering time.
So every time we compile it or auto compile it, then we are just use our quota.
Yes. Okay, let me show you an example. For example, I cannot, let me show you this one. See? Okay, this one. And if okay, now it is automatically compiled, right? Okay, here you don't see my figure because I choose the fast mode. It can reduce the rendering time. If I choose the normal mode and compile it again, okay, it's now overlay is more general today to give me more. Otherwise, I cannot compile it. Maybe during the peak hours, I don't know. Okay. So actually, when the paper was submitted before the CPR deadline, okay, I cannot do it. Okay. All right. Okay. So this is a list of the CPR 2026 template. Let me explain some of them. So first, take a look at this one. IEEE NAT for NAT.bst. This is the IEEE format controller. Okay. It will, for example, the IEEE format, if you have the reference, it will show 1, 2, 3. Okay. If you rather than the author's name and the year. So where would you see this format? Usually in the medical journals, they prefer this reference format. Okay, but IEEE 1, 2, 3, it is controlled in this file. And the second, because IEEE supports many different conferences. For CPR, how to control the CPR format? For example, Figure 1, this is CPR format. And Fig.1, this is ECCV format. They are different styles. And for example, if you have a table and a figure, and you have a caption. For table, the caption should be at the top of the table, but the caption will be at the bottom of the figure. So this is CPR style. Okay, there's no good and wrong, just for historical issue, I think so. Okay. And the GitHub and the Git, no, they are Git files, not important for our LaTeX, right? And build it. So you see here, this is a PDF. Okay. And okay, so this is the Text Studio user interfaces. The first one, the left folder is there are several tabs. This is the folder tab. So you will see every file in the folder. And this one is the structure panel. You will see, okay, here the main.txt is the primary text file. And it will include the bibliography. The bibliography is written in the main.bib file. And the main text will include some 5 supporting document. Is the printable, abstract, intro, format, and final copy. So you can see, where are they? They are in the section folder. So there is a folder called section, sect. And if you, let's take a look here, easy. So here, if you expand the sec. So you will see the 1, 2, 3, 4, 5 files here. Okay, and all right. Okay, now we just introduced the editor and the environment. We are going to the comments because LaTeX is a comment-based typesetting environment. So if you open the text file first, okay, you will see, okay, this is the first comment, document class. So it is 2 points, the font size. 2 column. What is 2 column means? It means your document will be written in 2 columns. So for CPR, it's 2 columns. For ECCV and for ACCV, they are single column. And the letter paper means the size. Because CPR is an American conference, so the Americans prefer letter, and we prefer A4. So that's the difference. Okay, so they will print out the papers on the letter paper. And the article means they are this option just specify, okay, what is the output of the PDF file. And okay, the second command you will see will here, use package on the line 7 here, use package. What does it mean? It means you will use the CVPR style to control your output. And here are some commands. You see here, to produce the review version, you use this. If you want to produce the camera version, what will you do? Well, let me first show you what's the difference. First, you can see there are CPR submission and the submission number, right? Okay. If you replace it, here, command, and enable this line, right? And compile it again. So this is a difference. All of those reference line number disappear. Because in a camera version, it means your paper has been accepted. You don't need a reviewer's comment. So why do they need those reference number? Because so this number, because in the I should say rebuttal phase, the authors need to specifically tell the reviewers, okay, our argument on which line number is your answer. So they need those line numbers. But in the camera-ready version, no. They no longer need those information. And let me show something with you. Okay, here. You can see there are some errors, right? Ideally, the line number should be on the left-hand side of the first column. But here, you see they are on the right-hand side. So this is a problem of the LaTeX system. In some step, it makes mistakes, but you don't know where the mistakes is. Okay. So how to deal with this problem? I don't know. Let me try to delete all of those automatically generated files. Can I do it here? No, I cannot. And let me try here. Let me delete all of them. Okay, and ask my rendering engine to do it again. Okay, it works. Although I don't know where the problem is. Alright, okay, let's take a break. Okay. Alright, so this is a with and without review argument. We just saw it. Okay, and the next command we will see is the input. Where is it? Let me show you. Okay, here. This is the input. The input of first, the printable means. Okay. This is a printable file. Here is a printable. Here. Oh, okay. So let me scroll it. This is the file. Only have 3 effective statements. Only the 3. And so you will see a new. Okay. So first, let's explain what is the input. Input, just like the include in C++. It means you have a main.txt file, and if you want to load another file into the main.txt file, just use the input command. So here, let's go back to the main. You don't need the .text. It will know what you want to load is the printable.text. And in this file, you own these 3 C statements. So let's see a new command. So what is a new command? From this, you can interpret it as it defined a new command /red. And the definition of the /red is set a color red, and with the square parenthesis with 1 is the first argument. What is it? It's just a string. So if you use something like this, red and bird, then it will be converted into /color red and the bird. And then you will see a word bird with the in red. Okay, so this is a nested new command. The second new command is to do after lowercase. What is it? It is the color red and the first string, and this is the capital to do. It means you will use text-BF. Text-BF means bold and face. So this is a bold face, and color assign it as a red, and add the string to do first, then insert the first argument string. So this is my example. If I use the to do capital to do command here and eat ice cream, then here you will see this is the square parenthesis. Where are they from? They are from here. This is the left parenthesis, and this is the right parenthesis. And you will see the to do string here, to do. And the first string argument is where I assigned here, eat ice cream. So this is eat ice cream. So this is a command and the result. So we will see the next latex. Here, this is the next latex command, define color. So it's not difficult to understand. We define the color. It's called RGB blue. From the string. So what is the meaning? It means it will assign a color in the RGB format, and the R value is 0.21, G value, and the B value. In addition to the RGB format, you can imagine there are some other color space, HSV, hue, saturation, and the value, or RGBA. The A is the alpha channel. Okay, what do you need the alpha channel? If you want to get the transparency effect, then you need the alpha channel. So the defined color can accept several different color formats and their value. And the RGB is the most intuitive format. And where will we use the blue, the CVR blue? Okay, in its next command, use package, and what package we want to use? The hyperref. Hyperref is the one we mentioned in the previous class. It is this one. Okay, so if you click the number, you will jump back to the page or the equations. And here, where is the color? So you see this is the blue. And where is the color of this blue defined? Just from the CVR blue. So you can see, now you are using a CVR template. But if someday you want to create your own document, for example, your term project report, or other, okay, I should say all others answer, because I assume you will follow the CVR format to submit your term budget report. If you want to create another format and you want to replace the color, you don't want to use blue color, for example, okay, any color you like, you want to use red, green, yellow, or something else, okay, it's easy. You just to replace the number here, then you can generate the color you want. So this is the advantage of the command-based typesetting system. Right? Okay, so this is the hyper reference package. Here, so this is the MicText console. You can see here, this is the, let me enlarge it. Hey, sorry, what happens? I click a wrong button. .01Q is the version of my hyperref package. It's gradually updated because if they want to add some new features, they will release a new version. And yes, okay, right. And okay, so what I want to show is how do you know? Also, I showed this before. You can just how do you know how to use the hyperref package? Through the MicText. Through the MicText document search box, just type hyperref here, and you will see several of packages. In their title or in their document description contains the hyperref keyword. And of course, I know this one, hyperref underline doc is the one I want to read. So just double click it, then you will see this is the hyperref menu. It is, I think, more than, there are 18 pages. So if you get the detailed instructions, you can read the manual by yourself. And let's see next, latex command def. Okay, here def is just, what is it? It just define alternative or just a new string. So here, let's define. Here you can see conference net CPR. So because CPR, ICCV, and WCV are all supported by the CVF Foundation, so they almost share the same template. The CVF Foundation, they just need to replace the string CPR with ICCV, and then they can release the template for the ICCV submission. It's very easy. And year by year, there are the CPR and WCV conference. They just replace the number of year, 2026 to 2027. Then they can generate a template for the next year conference. So yeah, easy to maintain. And next one is the title. Something wrong here. Sorry. I need to scroll. Okay. So on the line 26, you see this is a title. And within the curly parentheses, you will see this is a string. The first string, LaTeX, in fact, it is comment 2. It will generate the leaves format, LaTeX in this format. And author guide for, so here we see conference name. So this is CPR. Okay. And here, you need to replace the title with your own title. For example, this is the title for our Chih-Yuan 26 submission. So this is TP square. Okay, so it is a long string. Here, I want to highlight this. You can see if I want to generate, if I just type 2, it will generate a TP2 deter. If I type the $sign and the hat and the 2, it will become the square. So this is the square is what I want. Right? Okay, that is the math expression. You need to use a pair of the $sign to tell the LaTeX rendering engine from the left within the scope of the pair of $sign. This is my mathematical expression. So let me see here. So this is the LaTeX the string, and the $sign with the slash alpha, it will generate the Greek alphabet alpha. And here, if you use the double $sign, okay, the difference of the single $sign and double $sign, the single $sign, it will be embedded into a sentence. But if you use the double $sign, it will expand the mathematical expression into a single line. So you will have more space to do it. So let me explain here. Okay, frax means fraction. So if you have fraction, you will have a numerator and a denominator. So the numerator here is the x to the order of n minus 1. So the head here, just like the square, it will create an upper script. And if you want to create the summation symbol, the command is sum. And with the underline, it is the upper subcapital of the summation symbol. And with the hat, you will get the upper. And here is the content of the summation. This is another example. Okay, here you see, because with the hat, after the hat, there are only 2. So the 1 is not affected by the hat. So it is not the subscript. It's just a regular 1. Okay? And this is not equal. You need to use the slash ne not equal command. Okay. And here, because we have a pair of curly parentheses, so LaTeX engine will understand. Here, we want to put the whole string 21 into the upper script. So this is x to the 20 square order, but this is only x squared. So, and here, this is the complex mathematical expression. Like first, here, this is the see, the left and the parenthesis will generate this one. And it needs to be paired with the right parenthesis. So this is slash right parenthesis. And within the pair of parentheses, in fact, there are 2 lines. So we need to use the begin array. And the C means centered expression. And for the first line, this is n plus n. Okay, so here for the second line is only n. And after that, this equivalence will generate this one, and the frac will generate this fraction. So here there's n plus n, and what is the name of this? Forget. Sorry, that's fine. Okay, and so this is the factor. So okay, so we will generate this one. Okay, and how to generate this square? We will use the over brace. And how to generate this one? It is the under brace. Okay. So this is the high learning curve of LaTeX. You need to know those commands first. Then you can create the mathematical expression you want. Okay, so let's see this example. If I want to express this, so this is the mathematical, the LaTeX syntax. So it is not so intuitive, high learning curve. But once you get familiar with that, okay, it will be easy to use. You just copy paste your source. It will generate the different the expressions you want. Okay, so let's take a look. What is the begin of end? You will see the begin and the pair frequently, and it might be table, begin of a table, end of table, begin of a figure, end of a figure, or begin of an equation, end of equation. Here is the equation array. Equation array, and then here is a star. Star means for CPR we have our page layout are two columns, right? But however, if you have a mathematical expression, it is so long, you cannot just place it into a single column. You need to use the two column width. How to do it? Add the star, so that the LaTeX rendering engine will know, okay, for this specific mathematical equation, I can use the whole page width to show this equation. So this stuff. And here, okay, 1 plus 2 is here, slash dots is here. And okay, let me explain the and sign here. The and sign is the symbol used in equation array to align several equations. So I tell the rendering engine, okay, align this equation equivalence symbol and this equivalence symbol and this will vertically. So you see this is first one, second one, and so on. They are aligned here. And then, okay, this is something like we saw before. Okay, so you saw the mathematical equation, but mathematical expression here we need to. I want to show you the difference between equation and the mathematical expression. Equation means you will have an equation number, because you can create your mathematical expression anywhere. But let's show this again. In the hyperreference, you see the equation number, right? So this equation 13, equation 14, right? How to create the equation number? You need to use the begin and the end equation. Right here. So begin of an equation and the end of an equation. Then LaTeX will know, okay, this is the equation. You want to clearly give it a number. So it will assign 1, 2, 3, etc. So you don't need to specify the number. LaTeX will automatically reorder the numbers. Okay, so there's I believe until here you will find there are too many comments to remember. How to solve the problem? We are not the first one to encounter this problem. So you can just download the two files. Let's show the first one. They are available online. Okay. So this is written in 1995, 21 years ago. And this is the introduction to the LaTeX. So just quickly go through it. It shows many widely used equations, or I should say, okay, here, how to control the font size. So there are different comments. Tiny and script size, footnote size. So once you have the document and you want to, okay, you can just quickly get the answer here. Of course, you can get the answer from large language model, no problem. Okay. And then here is a lot of example. If you want to use different font, what is the comment? The comment is SF, the sans serif, TT means type right, etc. And there's a lot of accent symbols. And okay, there are some, for example, Dagger. Okay, this is a widely used symbol. So I want to show you there are some existing documents you can just grab and take a reference to, so that you don't need to remember every comment. Let's see this another one. This is also in introduction to LaTeX. So this is a list, and I get some example. For example, here it shows how to write, and this is the symbol of all alphabet. Greek letters, and okay, how to write the mathematical expressions, and there are some how to write the cosine, sine function, etc. So I just want to show you resources. Okay, you can just download and use them. So this is a quick check. For example, if I want to use those symbols, this is the link compared the command. This is the Greek letter. Okay, so let's go to the next LaTeX command, author. Here, okay, this is reference. Author, and here, this is a lot of strings. It will generate a result like this one. And so it's easy. If you just have two authors, just replace those strings. Or if you have three authors, what to do? Add and comment and information of the third author, then it will generate the CPR format. And how? Okay. So here the author is created in fact, this is a macro. This macro means if the rendering engine see this comment author, then it will know what is the string it should use. Okay, and here, if you open the cp.sty file, you will see this is the make title comment. And the make title comment, you can see this at author. What does it mean? It will use the author string where you defined here. And so where is the make title? The make title, let me show you, it is here. Can you see? This is the make title. So it means you provide the author's information, and the make title command will grab those information and to render your result. And the make title command, they are written in the cpr.sty file. In fact, I should say the make title, it is a built-in command in the document class, but you can overwrite it, and the CPR conference overwrite it to provide a unified format for all submissions. But can you modify the make title by yourself? Of course you can. Okay, if you because some people need to do it. Let me explain why. You see, the first author, second author, they assume they come from different institutions. But if they all come from a single institution, how do you do? Okay, so if you repeat the institute, it doesn't make sense. So sometimes you need to modify it. And since they are all open comments, so you can do it. But you need to be familiar with how to do it. So here you can see there are a lot of comments of LaTeX. Let me show you. New page. Definitely create a new page. And null, do nothing. If toggle, what does it mean? It will check whether the variable CVPR reparto is a variable. If it is true, then it will create a V-space. V-space is vertical space. Okay, and how large of the space, and the V-space skip. Then it will use begin center and end center, means what? Align center. So you will see there are two commands that will generate the same result. The first one is the begin center and end center, and the second one is just a slash center. Okay, they are highly similar to each other. Right. Okay. So this is the if toggle. So using the if toggle command, so it's somehow like this is a code. Since it's a code, so you can I should say the creator of the file can easily control the expected result depend on different variable. So this is the case I show you like this one. Okay, this one. Okay, because I just modified a single line. So this is the first format, and this is the second format. Right? Because LaTeX is something like a code, so you can modify a lot of things just to change a variable. Okay. Okay, and okay. So let me explain. There are two types of LaTeX command. The first is a macro. It's just expand the text. It's like the define in C++. So read to do typo. Sorry, and to do this is the author and the make title are all examples we see. And another type of LaTeX commands are primitives, like the int, return, resize in C++. They are the elementary command for the rendering engine. They include define, if toggle, large, or line skip. Those one. Okay. And okay, now you know I should say, let's go back to the file. Until here, you can see, you know input, right? So input section and 0 abstract, it will include this file. Okay. And so this is the first section, abstract, second section, introduction, third section, formatting, and the fourth section, final copy. So if you take a look at this, it will like this one. Okay, so for the first section, abstract, right? So you can see if I open the abstract, this is a very short sentence, and it will be shown here. And this is the first section of introduction, and I click the introduction. Okay, so this is the file. All of their content will be rendered in this section until this is until. Okay. So this is the beginning of the second section, and the second section is here. Okay, yeah. So what I want to show you is from the main text, you can understand all command until here, and let's see the next command. We will see small bibliography style and bibliography. Okay, small. Yeah, it is the command to control the size of fonts in this scope. What scope? From this left curly parenthesis to the right scope. Only control this one. Okay. And the bibliography style, it will load the IEEE net full name bibliography style file. And the bibliography means it will use the BIB text to compile our main.bib file. So this is a BIB file, and we just need to edit that. So this is a given example of this LaTeX template, and this is the generated results. So you can, and then, yeah, there are many entries, and those entries are all defined in the IEEE net full net.bst file. Open it, you will see it. So here you can see what entries they use. In fact, for most cases, we only use those one. Author, the name of the authors, title, journal, okay, journal. So this is for journal, and this is for miscellaneous. So in the miscellaneous item, there is no journal entry. Okay. And the year, note, page number, and volume. Yeah. For conference, there's usually no volume, but for journal, sometimes there are volume. All right. And okay, let me show you some common mistakes to edit the bibliography file. Here, okay, if someone created this item, then what will be the error? First, activity net, the N, yeah, we know it, and the CVPR, they should be capital. But from the source, no, they are not. Okay, and why? Why? You will see it because if you just as a Google source of ActivityNet, okay, then Google, they will return you this bibliography. Many people just copy and paste it to their BIB file and render. So the source is wrong. The result is also wrong. Okay, so let's correct that. ActivityNet, because I want the capital N, so I add the parentheses here. Then the PDF, the bibliography, BIB LaTeX will know, okay, what I want is the N. And the CPI is not only supported by IEEE, it also supports by CVF. So the correct title should be IEEE/CVF references, conferences, and the C need to be capital, and the CVPR, they are capital. Okay, so this will generate this result. This is correct. The most formal reference. But some people, they prefer initialism because it can make their paper look more compact. For conference paper, that's fine. For journal paper, no. You need to be very, very formal. You need to use this for every reference. And in the template provided by CPR, they provide those initialism already. Even they are very short initialism or slightly longer abbreviation. So if you, okay, the BIB text, they will read those string defined first. And when they found the same definition, for example, this is PAMI, IEEE transaction on pattern analysis and machine learning. Okay, when they found there is another PEMI defined here. Okay, they will replace the old PEMI with the new PEMI string. So the order, which is the first, matters. And if we use the initialization, so here the book title, I just use the CVPR forward, and the BIB text will find the CVPR means here. Okay, the CVPR is CPR, so it will generate this result in CPR. Okay, it will shorten my reference. Okay, now let me get into another topic, tabular and table. Okay. Here, if you want to create this result, so this is the command. First, you need a pair of table. What is the difference between table and tabular? In LaTeX, table means you will have a table number, or should say table index. Because if you have multiple tables, then your hyperreference will need to go back to the table 1, table 2, or table 3. And in the CPR format, the caption of the table is at the top of the table. So this is the tabular and this is table. And the table will have a caption. So the caption here is results. Our is better. Results, our is better. And the matrix of your data is the tabular. So this is the begin of the tabular. And there are some control. So the at and the null means you don't want to see any padding between the left margin and the first column. And because there is no such at null between the L and the C, L means for the first column, left, align then left. So this is the first column, align left. And for the second column, center. And there will be plenty of padding. So here is the padding. You can see it. I should say invisible, but you can feel it. Okay. This is the padding. Use the default padding. It is how large is the padding? Usually 1 or 2 characters. Yeah. And after the second column, no padding. So here, after the second. So this is the end of the tabular, and this is the end of the first column. They are in the same size. Right? Okay. And this is the 3 commands: top rule, middle rule, and the bottom rule. What will they generate? This is the top rule. This is the middle rule, and this is the bottom rule. What's the difference? The top rule is slightly thicker than the middle rule. Okay. So where are they from? In fact, the 3 commands are from the book tabs like a package. And where do we include, I should say, use the package? In fact, it is written in the CPR style file. So that's what I say. They define every detail of the format. You don't need to control that. You just need to put in all your data or sentences. Then it will generate a very elegant PDF document. So that's the advantage of using LaTeX rather than Word to create a document. So it will be very useful when you write your master thesis, because you just put in your content. You don't need to care about the format. It will save a lot of time. Right? Okay, and here you can see this is the and sign and the double slash. It means this is a separator for the among the column, and this is the end of a row. See? Okay, see, this is also a table. How to create this table? This is the core. So you can see begin a tabular, and this is a vertical line, and left a line right, vertical line, a line right, vertical line. So this is the first vertical line, second vertical line, and the third vertical line. And then all of those texts are line right. And then now you can write it. So the $ pair at end means you want to use a mathematical expression rather than the simple letter. Because so for the mathematical representation, you can see the font is different, and it is Italian. Right. Okay. And here, okay, just write those. So the H line means a horizontal line. Okay. So this is the first horizontal line, second horizontal line, and the third horizontal line. Okay. Yeah. So you can create a table in this way. Okay, now let me talk about the tabular. Tabular is a comment. And the limitation of the tabular is there's no automatically text wrapping, no tablet scaling, and no page breaking, and very poor vertical spacing. Well, let me show you an example. If this is my source text command, and I have some sentences very long, okay, if I just use tabular, then this will be the result. It will exceed the limit of the column width. So how to overcome this problem? You can use other package. For example, tabular X. Okay, first you need to import it. Use package tabular X. Then just replace the here. In our previous slide, it is in begin tabular. Here it is begin tabular X. And there is a new argument. You can control the width of the tabular. So this I use the column width. And the other things are similar. And so even though I have a very long sentences, it can automatically swap. So this is a generated result. And you can see this is my column sentences. The length of the tabular is the same as my column width. So it will look elegant. Okay, but sometimes you will have trouble. For example, in this case, what is trouble? The trouble here is I only have two columns, but this is the third column, because our first column makes one hard frame, second column. This is incorrect column separator. Okay, so the rendering engine will tell me something wrong. I cannot understand what you are writing here. And okay, it will show the error message like this one. On line 118, okay, there are something wrong, and this is the error message. Okay, so where can I find the error message? They are okay here. View show. Okay, message panel here. But currently, because I don't have any error, so nothing show here. Okay, and because the text studio is an integrated editor, so it will also highlight the error in the editor panel, like this one. So this you can see there's a cross, red cross here. So you will notice it. Okay, but sometimes the error is too complicated. if I cannot solve it, I will ask Gemini or ChatGPT and just copy paste the error message. Usually, I can get a very good hint to solve this problem. Okay, and the latest one is we see how to create equations, how to create tables. This is how to create images. So this is, in fact, we just need this include graphics command. Yeah, right. Okay, include the graphics. In the first argument, we need to assign how width or how height the rendered graphic should be. And the second will be the source of the image. So here the figures, the figure framework overview. So this is the figure. Okay, so it will generate a result like this one. Okay, if you just know this comment, it's enough for most cases. But here is a book. Free. Okay. And this is a shorter version. In fact, it's a very thick book. Okay. And the PDF, from the PDF, you can see, okay, so this is a graphic. You can use LaTeX to render this one. Okay. And also something like this one, and even some. Okay, so this is the elementary information of the. Okay, so any kind of curve, any of this one. Okay, yeah, you just need those. If you know these comments, you can generate this one. So, yeah, for example, this figure is highly complicated, but it's feasible. So that's what I say. The learning curve of LaTeX is very high. If you want to create some very fancy features, but it is feasible. Right. Okay. Right. So I think that's all. Yeah. Okay. Any questions?
Do you think we should read the books or we should learn from LLM?
Either way is fine because you are learn. If you want a very systematic learning approach, you can read the books. But you want quick answers. You don't want to spend too much time there. Large language model is useful. Oh, by the way, if you have the basic concept, then large language model is very useful because you just like this one. If I want to, okay, here. If I just want to, for example, I know some symbol, and I don't know what is the correct command to generate this symbol. If I can describe this symbol to the large language model, the large language model usually can quickly give me some hints, and I was yes, that's what. That match my memory, so you can just solve the problem soon.
Because I think it's like a very high learning curve.
Mm-hmm.
But as we just learn some foundation concepts.
Yes, sure. Everybody starts from the foundation concepts. Any questions? Yes.
Do we have to use LaTeX for the project and the paper?
I should say I recommended you to do it. Yeah, and it's up to you because if you want to be an advanced researcher, this is the way you have. It is the capability you need to have.